So we are going to be talking about the side splitter theorem today, which it's got a neater name than maybe some of the other theorems that we have, but the name actually kind of explains what it is. It's when you've got the sides being split, and the sides here are the transversals. Notice in this diagram, we've got three parallel lines, and we've got two transversals cutting through. Yesterday we were going through how to solve proportions because you can see on the left that we're just setting up a lot of proportions. And the side splitter doesn't have, I'm sure there is a formal definition for the side splitter theorem, but we're not going to write one down. So that blank below it, I just want to kind of have you guys write down a very, very important idea. That when you have a situation where you're using the side splitter, you are always going to be setting up a proportion using, and I'll use this phrase over and over again, using a pattern of correspondence. And so I'll use it enough, we'll use it in context so it'll make sense. So all I'm going to write here is set up proportions using a pattern of correspondence. And this will be maybe a little bit redundant today because I'm going to go through a lot of examples and stuff. You're going to probably be saying, okay, I think I get the point. You don't have to go through more. But it's really, really important that we go through this because you might imagine there's going to be a lot of mistakes made by students whenever we're trying to solve problems setting up proportions.
We use set up proportions
using a pattern of correspondence. Okay, so let's look at this diagram on the right, and let's look at the proportions that are already set up. Now, these are set up correctly, so we're just going to kind of pay attention to what's going on. So in the very first one, I've got BC over CD equals, let me change the color on this real quick, equals GF over FE. All right, so if I've got those, so let me go ahead and show BC over CD equals GF over FE. And so the pattern of correspondence we're talking about is, notice that BC and GF, the numerators in both of these, are being split by the same parallel lines. They're on different transversals, but they are the same corresponding segments for their transversals. Does that make sense? All right, and CD and FE, same thing. They're both being split by the same parallel lines. So you've got to find something that corresponds to every piece before you can actually create a proportion out of it. All right, and that is a theme that we'll come back to. So let's look at another one, and I'm going to erase this. All right, now we've got AC over AD equals AF over AE. All right, AC over AD, and we're looking at all these because there's different ways we could set up this correspondence. So notice that we're using some overlapping segments right here, but that's okay. We can do that. So AC over AD is going to equal AF over AE. So here's AF. Again, that corresponds. And AE. All right. All right, so again, the pattern of correspondence is that we've got this segment over the large one. So we're going from this intersection point to that second parallel line, and then the entire segment is the same as the corresponding parts on the other transversals. So the intersection down to the second parallel line, and the intersection all the way down to the very bottom. All right. So it's worth it seeing all these different examples so that we can see all the different possibilities. So let's look at this one now. This one's going to be a little different. BC over GF, equals BD over GE. The pattern doesn't always have to be comparing one part of the same transversal to another. Notice what's happening here. BC over GF, BC over GF. Now we're comparing the corresponding parts within the same ratio. So BC and GF correspond, and BD and GE. Here's BD, and there's GE. So a pattern of correspondence. And here, the way I would kind of say it in my head, and it might make sense to you, is in the first ratio, I'm going left to right. So in the second ratio, I have to go left to right. All right. So if you like to think of it kind of, okay, left to right, therefore left to right, kind of keeping that pattern going, that's the main idea. Like I said, it might be a little bit redundant because you might already be saying, all right, yeah, this is making sense. I get it. Let's move on. But I want to look at the last two. AC over BD, AF over GE. AC over BD, let's go ahead and show that. AC over BD, again, a little bit of overlap between those two. And then that's going to be the same as AF over GE. There's AF, here's GE. The same kind of overlap, the corresponding parts. And I'm drawing on the diagram because it's really important to make that visual connection between where these ratios are coming from, what the actual segments mean compared to the diagram. All right. And last one, just for completeness sake, let's look at AD over AE and BC over GF. So AD over AE, we got the two big ones right here. AD over AE and BC over GF. So the actual lengths being compared don't matter. So we have the longest possible segment being compared to the shortest possible segments right here, or close to the shortest possible segments. And they are going to be proportional. This proportion will hold true because we still have that pattern of correspondence. And that's one of the key ideas, that this relates to dilations in the sense that these are growing proportionally, growing by a certain scale factor. So this side on the right is going to be a little longer proportionally than the segments on the left. Now the scale factor here is going to be some weird decimal, and that doesn't matter to us. But we can see that they're all growing proportionally. All right, any questions on this idea overall? Okay, hopefully this was pounded in your head enough so that the next part here will be very simple for you. You've got this next diagram. You can see all the points. They've set up a proportion for the most part. Take some time to fill in the blank with what's missing. And I know some of you might have already done that. So everyone now take the opportunity. Fill in those blanks with the correct length. All right. So BY over BD equals TM over what? TE. Okay, everyone agree? All right. AY over AM is going to equal DY over, what goes there? EM. All right. So if you didn't come up with this, see if you can figure out why. And if you still aren't sure why we did it, we're going to have some time in a minute where you'll have some work time and I can come around and help you and explain why this is the case. All right, and last one, TE over BD is going to equal something over AD. What is that something going to be? AE. All right, so you don't have to shout out if you got them all right or not, but just real quick, stopping right here, 1 to 5, I want to get some feedback. If you just had to set up proportions like this, how confident are you that you could do it? Feeling... Okay, overall feeling like it's not too bad. That's good. So these next three, this is going to kind of show you not all of the possibilities, but it's going to show you some of the things that you'll need to be aware of moving forward. So you've got 3 problems right here. And notice in these examples, this is what it's going to look like for your problems on your quiz. notice for these examples, they don't have a proportion set up. So you need to come up with your own pattern of correspondence. There are 8 different proportions you could set up that are all correct. There's not just one way of doing this. So what I want to do this as a class. Can anyone tell me the way that they might set up their proportion? And I'm just looking at A to clarify. Oh, well, let me go ahead and get you started. You're going to have to do... I'll start you off with the proportion. So you're going to have a fraction on the left and a fraction on the right. So what might you have on the left ratio? All right. Yeah, go ahead.
Is it 5 over x?
Yeah, let's start with 5 over x. That works. 5 over x would equal what? 6 over 4.5. And I told you there are 8 different ways of setting this up. So that's not the only way. So before we just go ahead and solve this, let's come up with another way. Let's come up with 2 other ways of setting up this proportion. Yeah.
Okay, x over 5.
Yeah, we could do x over 5 equals
4.5 over 6.
4.5 over 6. So we just took it and flipped it, but that's okay. We'll get the same answer for x, and that's what we're interested in. All right, and let's try it one more way. 5 over 6. So, okay, sorry. 5 over 6 equals what? X over 4.5. All right, so, and again, you could keep going from there. Now, hopefully you're starting to see kind of the pattern, what you're looking for. And you could probably find all 8 of them now, but you don't need to. You only need to set up one way that works. So what I'm going to do is I'm going to erase all the other ones except for the first. And let's go ahead. That's what we did yesterday as we were solving these kinds of problems. So remember yesterday we were doing our cross products. So you got 6x equals 5 times 4.5. You guys have calculators. And what is 5 times 4.5? 22.5. Divide that by 6. And x equals 3.75. There's your answer. You will frequently get decimal answers, and that's totally okay. So just be prepared for it going in, and it won't be a problem. Again, yesterday with all the practice with proportions, you should have mastered just the solving of proportions yesterday. That was the goal of yesterday. So if you are still confused on that, you got to get that mastered sooner rather than later. If you need to come talk to me to do that, come talk to me. But now you can see, obviously, the hard part is going to be finding how to set up the proportion. And the easy part should be solving. So let's look at the next one. And we're going to do this all as a class. I'm not just going to say, okay, you guys do this. So the next one, we have to have a pattern of correspondence. So what works? We're looking at B now.
That's how you do it.
Go ahead.
4 over 1.
You can do 4 over 1. That works. 4 over 1 equals what?
X over 1.
Perfect. All right. And I'm not going to go through all the different ways of setting up proportions. But I do want to point out this 2.5. Can we use that? No. Why can't we use the 2.5? What are we missing?
The middle, the other side.
Yeah, we're missing its corresponding part. if we're going to set up a proportion, we need to have the corresponding measurements. So I need to know what this value right here is. So this red one that I just marked, if I don't know what that is, then that 2.5 is just extraneous information. It's there to distract you. Okay? So the only numbers we can use to set up a proportion are these 4 on the top and the bottom. So I will just go ahead and cross this out. So that's one thing you're going to have to be aware of when you look at a diagram. Are there numbers on here that don't work for me? I can't even use them. They're just distractors. All right? So from there, I'll let you guys solve the proportion in a minute, but let's go ahead and set up the last proportion, and I'll put up the answers to this in a short while. All right, so the last one. Everyone focus on that. What are we going to do for this? 5 over 4, and we'll come back to this, equals what? 6 over x. So explain how you got the 5 over 4. Okay, there we go. And we've got this right here. It already tells us that's 9. And therefore, when you do your subtraction, you get your 4 right here. Why did we need that 4? There you go. That x corresponds to the length of 4 right here, not to the 9. There's nothing on the left that corresponds exactly to the 9. But we can do our subtraction, get the 4, and those now correspond. So one way you can kind of think about it, if I drew a squiggly line right here, to show those are corresponding, then this squiggly line would show that those correspond as well. All right, I'm not drawing the dash line because they're not congruent. All right, so now go ahead, take some time to solve those, and I'll just put the answers up in a minute. All right, I'm going to put the answers up for the first 2 right here. And if you guys are still working on them, you can just check in a minute. Like I said, the back side of this just has a lot more practice. So if you got these 2 and you're feeling like you understand it, you can start on the back and have an answer key. Don't move on to page 3 because that's what we're going to do on Monday. Start looking at those. That's a different theorem. And anyways, I'll write the answers down. Just happen to be the same. All right, so for the rest of the class, just get practice. I'm going to be available if you have questions. But make sure that you're picking up on this idea of the pattern of correspondence coming up with the right proportions.